Good morning, guys.
Good morning, sir.
How are you? How are you all?
Good, sir.
Fine.
How are you?
Fine, fine, fine. Can we revise the last day's topics, last class? At least enough.
Yes, sir.
Okay, 1 minute. Good morning, guys. Can you revise at least any one of you? Any one of you? What we discussed in the last class? We discussed about different types of charge distributions. Different types of charge distributions. Yes or no?
Yes, sir.
We discussed about Coulomb's law.
Yes, sir.
We discussed about the different types of coordinate systems,
Yes, sir.
which some people has not unmuted, I think so. And we also discussed about the scalar form of the Coulomb's law in the vector form, but only we have done one problem in the scalar form, but not in the vector form. But we discussed what is the difference between them. Yes or no?
Yes, sir.
Then we discuss when we use Cartesian coordinate system, when we use cylindrical coordinate system, and when we use spherical coordinate system. Yes or no?
Yes, sir.
Okay, right. And today, I want to just have a very good review about what you have done. And please unmute, please. Children, unmute, please. Okay, thank you. So just I made some my own writing some. I made my own notes as a PPT. Just we will discuss meanwhile. Just as a revision, can I again recall you what do you mean by a scalar product and what do you mean by a vector product?
Yes, sir.
That which has only magnitude is a scalar, that which has a direction is a magnitude and direction is a vector, and that which has both only unit magnitude and a resultant direction, that is called as unit vector. Yes. Yes. No. Yes. Okay. Are you able to see my PPT?
Yeah.
Right. Please, I repeat again and again, all of you just to concentrate on this. This is a very, very, very important topic, Amma. As an ECE student, it is more important for you throughout your life, wherever you go, anywhere. Why? Because again and again, we will not get time to discuss in detail about this. So please, all the students, please be more attentive, more concentrate on this particular topics. If you have any doubts, at the end we will discuss. Why? Because these point I told you in the last class. Why we are using this, how we got this, and where we use this. If you study in that point of view, then every subject will be very easy. That point of view only we are lagging. Only we just depending upon the exam point of view or depending upon the requirement, we will study and we will implement it and we will just forget about it. So I repeat again, Coming to the concepts of dot product and cross product. You know about dot product and cross product. Right? What do you mean by dot products? I think here I would write one more statement. A bar dot B bar is equal to mod A bar mod B bar cos theta. Are you able to see the cursor, Amma?
Yes, sir.
Yes, sir.
So A bar dot B bar is equal to mod A bar mod B bar cos theta, or OA bar dot OB bar is equal to mod OA bar mod OB bar cos theta. Right. So do you accept that A bar dot B bar is equal to mod A mod B cos theta, and A bar cross B bar is equal to mod A mod B sin theta? Please, at least I want one or two for the answers, Amma. Not I'm expecting for all. I don't know remaining how you are. It should be an interactive class, Amma. Then only if you have any doubts or any clarifications, you can do it now. I had made an into mark for the first statement. A bar cross B bar is equal to mod A bar mod B bar sin theta AB into. This is not the right statement. What does it give the meaning? So the correct statement is A bar dot B bar is equal to mod A bar mod B bar sin theta AB. That is nothing but angle between the A and B into A n bar into unit vector. This is the correct expression. Do you accept this? Anyone? At least one answer.
Yes, sir.
Right, good. Then I will ask a simple question. Why A bar dot B bar is with cos theta? Why it is not with sin theta? Why A bar dot B bar is represented in terms of cos? Why not with sin? Anyone, please. For you, I made a small diagram at the right side left corner. This is the adjacent side, hypotenuse, and opposite side is the theta. And even I had made the vectors A bar, B bar in order to make you more clear. Why dot product is only with cos theta? Why can't it be with sin theta? Please give me the answer. Anyone, at least one or two.
Because cos theta is equals to adjacent side by hypotenuse.
Okay, that is the functioning of cos theta. Okay, fine. Why, on what basis the dot product is considered as? I think have you got a poll question, Sama?
Always cos
No,
angle is less than 90 degrees.
Okay, one answer. Good. Have you got any poll questions?
no, sir.
Okay. Meanwhile, you will get the poll questions. You answer for that. If you get the poll question, just remind me. Because at any time I may post one or two questions. Okay. Cos angle is between 90 degrees, and one more cos product magnitude gives sine. Okay. Cross product magnitude gives sine. Okay. Anyone? Anyone? Please, anyone? Why? Because we are using this from our BTech first year or even in intermediate. But what is the logic behind it? One vector is projection over other. Why we want to project one vector over other? One answer given. At least some people are responding very good. Why we want to project one or other? Please. Are you anyone at least? Two vectors have product value 0 when perpendicular. Okay. Any other answer? At least you can chat, post in the chat group. Just think this is not an exam or this is not a something else, punishment value, or just because the two vectors have product value of 0 when perpendicular. Okay. So cos 90 is equal to 0. So that is 0. Okay. Okay. Anyone? Anyone? Because we need cos component. Okay. We need cos component. Why we need cos component? Why not sine? That is my question actually. Why only sine? Oh, sorry. Why only cos? Why not sine? Okay, good. At least some people has given some answers. Very good. Just in right angle triangle, two vectors resultant is adjacent or opposite. Okay. Okay. Anyone, Amma? Right. So here, the simple logic is A bar dot B bar. The effect of A bar on B bar or B bar on A bar. For example, dot product is nothing but the effect of the vector, one vector on the other vector. It means if you want to study about the effect of one vector on the other vector, then both the vectors should be projected on the same line. For example, if two people wants to fight, both the people should be in a ring or in an area or nearby. If one fighter is moving in one direction, if the other fighter is moving in another direction, can both the people fight? They cannot fight. But dot means multiplication, the effect. So here we want to study the effect of B on A or A on B, what it may be. How do you take it as? So if you want to make the study of one vector on the other, then this vector should be projected on the other vector. This vector, this B vector or A vector, what it may be, that should be projected on the other vector. Then both will be on the same line. Then we can have a study about that. Right? So here the simple logic is if cos theta is equal to OA by OB. So if I multiply OB with cos theta, then if I multiply OB with cos theta, then that is nothing but what? OA. If I multiply OB with cos theta, then that is nothing but OA. Means OB is going to be projecting along OA. That is the thing. If I don't multiply cos theta with OB is in one direction, OA is in other direction. So I will not get the resultant. So for example, then you can ask the question, sir, if I multiply OB with sin theta, what happens? Okay, if I multiply OB with sin theta, what happens? If I multiply OB with sin theta, I may be getting this perpendicular direction between AB. I may be getting the perpendicular direction between AB, but OB is not projecting on OA. If I make the value as sin theta, dot product is nothing but effect of one vector on the other. If I want to find the effect of one vector on the other vector, both should be projected on the same. or both should be kept in line. If I take this OB and OA separately, both are not in the line. If I multiply with sin theta is equal to, what is the opposite? BA by OB. BA by OB. Right? So BA is equal to OB sin theta. So OB sin theta is nothing but perpendicular line. OB sin theta is nothing but the perpendicular line, but not the resultant of OB on OA. Unless and until I multiply with cos theta. If I multiply OB with cos theta, ante now OB is now OB is projected along what? OA. So due to that reason, dot product is always considered as cos theta only. Then only we can find the effect. Otherwise we cannot find it. Is it clear, Amma? Any doubt you can ask me. I'll clarify. Anyone? Okay, fine. So this keep it in mind, Amma. Definitely, simple question. If you think in the other sense, you'll get the answer. Why not sin theta? Why not cos theta? Then cross product. A bar cross B bar is equal to mod A bar mod B bar sin theta. A bar cross B bar is equal to mod A mod B sin theta into AN. Into AN. That shows the resultant direction. AN, I told you in the last class, what is the difference between a vector and unit vector? Vector has some magnitude and direction. Vector has magnitude and direction. Unit vector has only unit magnitude. That doesn't affect any magnitude, but it shows the resultant direction. For example, this cross product is represented by right hand thumb rule. Basically, cross product is represented by right hand thumb rule. If you close your fingers like this, if the fingers represents the two vectors, then the resultant direction is the thumb. Then are you able to see my video? Then the resultant direction is the thumb. So here A bar is one vector, B bar is another vector. A bar and B bar are two vectors. But what is the resultant of A bar and B bar? That is along the thumb.
Perpendicular to them.
Perpendicular. So perpendicular is the resultant direction of what? Perpendicular is the resultant direction A bar and B bar. Ante the final direction of the two vectors A bar and B bar is C bar. So unit vector will be along what direction then? C bar only. Right? For example, if A bar is only there, if only A bar is there, for example, along A bar, it has some magnitude and direction. If only B bar is there, it has some magnitude and direction. The effect of both is C bar. So the resultant direction is always represented by the unit vector. So unit vector represents the final direction of any two or more vectors. Any two or more vectors resultant direction show that is nothing but the unit vector. Right? So for the first question, for the first option of cross product, if it is A bar cross B bar is equal to mod A bar mod B bar sin theta AB. For example, what is the modulus of A? Some value 10. Modulus of B, some value 20. What is sin theta? For example, sin 60 or sin 30. What is the answer? Or sin 90, you take it 1. So what is the answer of A bar cross B bar here? What is mod A bar? We are taking it as 10. B bar 20. Sin 90 is
1.
What is the final answer? 200. 10 into 20 into 1. 200. Yes or no?
200.
So 200 is a scalar form or a vector form?
Scalar.
Scalar. So this notation is a wrong notation. Due to that is why, because the students know the equations, but they'll be doing the small mistakes in the small notations like this, misleading of. So compulsory, this cross product should have some resultant direction. So that resultant direction should not affect the magnitudes, but it should affect only the direction. So that what I have done is A bar cross V bar is equal mod A bar mod V bar sin theta of AB into AN bar. So now what I got the answer? Mod A bar is 10, B bar is 20, sin 90 is 1, 10 into 20 into 1. What is the answer? 200. 200 into AN. AN, unit vector. So unit vector has what? Direction or not? Unit vector has the direction or not?
Yes, sir.
Yes. So in the right hand thumb rule, the cross product is represented by the right hand thumb rule. So what does it represent? A bar cross B bar, resultant direction is along
I'm C then.
C bar. So some direction should be there. Which which notation is the correct one? First one or second one?
Second one.
Second one. So this is what we have to take care into consideration. Dot product is always a scalar one. Music. In between, we are getting some music. Just relax, guys. Ayyo, అయిపోయిందమ్మా. Okay, thank you. So here, if you so now I think you got a very good clarity about dot product and cross product. Then why cross product is use of sign? The resultant of two vectors is A bar along B bar or B bar along C bar or perpendicular to both? Perpendicular to both. So perpendicular direction we will be getting with sine or cos?
Sine.
Sine. So due to that reason, the cross product is always represented by what?
Sine.
So due to that reason, the cross product is always represented by what? I request the students, please unmute yourself. If you answer only, just you mute yourself. If you answer, unmute. Please, this is a very important topic, Amma. Why? Because again and again you will not discuss anywhere. And this is very simple and very easy, but we will have a small confusion. We are using this, but we don't know why it is the analysis behind this. So please just concentrate. And this is very important in throughout our life as an EC student. Just please cooperate, Amma. So here, so now you got an idea, I think. So why we are using sine for cross product and why we are using cos for dot product. Yes, Amma?
Yes, sir.
Right. So cross product we can use by taking the cross product of two vectors. What do you know? A bar cross B bar. So A bar is equal. This is what type of coordinate system I had used? AX, AY, AZ, and Cartesian coordinate system. So A bar along AX, A bar along AY, A bar along AZ, AX, AY, AZ. The B bar is BX, BY, BZ. Then the vector along AX. You know, A, B, C, D. What we studied in previous classes. AD minus BC. So you know this cross product values, how to find the cross product of two vectors. And this is one example what I had given. Right? So this is the in detail in analysis about a dot product and cross product. Right. We already studied in about the dot product and cross product. Then we'll study about a vector, a position vector or a distance vector. So every vector is represented by an arrow mark, right? where it has some starting point, end point. Starting point is represented by some coordinate system XYZ. End point, end point, end point is represented by some coordinate system XYZ. Please, meanwhile, if you get any poll questions, just remind me, Amma. I will stop for 2 or 3 minutes, then you can answer for that. Okay?
Yes, sir.
Right, thank you. So here, if I find the vector of AB bar, this is also very, very important. Just we will have a study about now itself, then we will use it in the coming classes directly. If you have any doubt, for the clarity, I had made my own notes with my own handwriting such that it will be more clear to you. So if we take this AB bar, so AB bar represents starting point is A, ending point is B. So how do you find the resultant of starting point and ending point is end point minus starting point. End point minus starting point. I repeat, starting letter will be the starting point. Next letter will be the end point. Then the resultant between the starting point and the end point is end point Cartesian values or the coordinate system values minus the starting coordinate system values. So x2 minus x1 into ax bar plus y2 minus y1 into ay bar plus z2 minus z1 into az bar. Right? So this represents a distance vector that which has some value. Suppose if I take x1, 1, 2, 3. Sorry, A. Suppose if I take this vector coordinate systems 1, 2, 3. B, 8, 9, 10. 8, 9, 10. Then how do I get this AB bar? 8 minus 1 into AX plus 9 minus 2 into AY plus 10 minus 3 into AZ bar. So this is the vector notation or the representation from A to B. Right? Suppose, so this is the starting point and the ending point AB bar. Suppose if the starting point is placed at center of the coordinate system. Suppose if this starting point is placed at the center of the coordinate system, then x1, y1, z1 becomes as what? 0, 0, 0. Any vector will be having its own starting point, its own ending point. Right? So starting point here it is 0, 0, 0. Ending point is x, y, z. So starting point is O. O means origin. Ending point is A. O, A bar. That is equal to A bar. That is equal to x minus 0. For example, if any one of you ask the question, sir, what about BA bar? In the first case, I written it as AB bar. Suppose if anyone asks the question BA bar, then
x1 minus x2.
Right. B letter becomes the first. B letter becomes the first starting point, and A becomes the end point. So don't get confused between AB bar notation and BA bar notation. Don't think both are same. Both represents the different directions, opposite directions. Right? So here BA bar is nothing but x1 minus x2 into x plus y1 minus y2 into ay plus z1 minus z2 into a. I repeat again and again, it's not compulsory to give all the three values. For example, he may give the values as 3, 2. Then what does the z value represents it as? 0. If he has given some value along x, that is the value of x. If he has given some value along y, that is the value of y. If z value is not given, then we have to assume it as 0. Why? Because in the coming problems, you may get such type of questions. If any value is given, you consider that as the value of the corresponding coordinate system. If the value is not given, just blindly consider that value along that coordinate system as 0. For example, if I give b bar is equal to x plus y. If I give b bar is equal to, actually here what I had given b bar is equal to x2 ax plus y2 ay plus z2 az. Suppose if I give the value as x2 plus y2, and x2 1 into x2, what is the magnitude of x2? 1. What is the magnitude of y2? 1. Then what about z? If I not
0.
give 0. So you'll be getting such type of doubts in the problems. So blindly you can take the given values on the values that which is not given, you can take it as 0. We have one problem corresponding to that. We'll be doing it now itself. So here if it is 0, 0, 0, so 0 means starting at O and ending at A bar. So such vectors, position vectors can be also called as A bar. If it is starting at one point, 0, and ending at another point, either we can call it as OA bar or we can call it as A bar. Why we are calling it as A bar? Why? Because starting point is what? Origin. Yes, starting point is origin. But I cannot call this the above. But I cannot call this. Okay, good. Most of the people are answering in the chat. Good. But here I cannot call this AB bar as A bar vector. I cannot call this this AB bar as A bar vector. Why? Because A position is not 0 or B position is not 0 values. A has some value x, y, z. B has some value x, x2, y2, z2. So due to that reason, I cannot call it as only A bar or only B bar. When I can call it as only A bar or only B
Sir,
bar?
poll question appeared, sir.
Yeah, right. Okay, right. Answer this one. Have you finished? You got only one question or two questions, Sama?
Only one question, sir.
Answer.
Okay. Finish?
Finish.
Yeah. By next week, I will share the syllabus copy and the notes what I had prepared and what I have with everything with you through Canvas. Actually, we are waiting for all the people to accept the Canvas of ADC. Once if all the people are accepted that ADC, I will copy that email IDs and I will share everything to you, whatever I had with me. You don't need to worry about that. Even short questions, long questions, even some videos if I have anything else, my videos or something very good. I will share it by next week, Amma. You don't need to worry about that. Even if possible, I'll send my written notes also wherever you require. Okay. As we get second poll question, you just remind me. I'll give break for you for 2 minutes.
Yes, sir.
Yeah.
Yes, sir.
Okay. Okay, please mute. Please mute. So here, so this represents A bar. A bar can be represented if it is starting at origin. If it's O and B, then we can call it as B bar. If it is O and C, then we can call it as C bar vector. Suppose if A has the positions of X, Y, Z, X1, Y1, Z1. If B has the positions of X2, Y2, Z2, X2, Y2, Z2, then AB bar represents what? A as the starting point and B as the end point. First one will be the start point, then B bar will be the end point. End minus starting point. So just like X2 minus X1 into X plus Y2 minus Y1 into AY plus Z2 minus Z1 into AZ. Then if I take it as BA bar, first one will be the starting point, B represents the starting point, A represents the end point. Then starting point B is nothing but, what is the notations of B? X1 minus X2, Y2 minus Y1, right? So here there is, how do you find the magnitude? How do you find the magnitude of AB bar? For example, if you see this AB bar, magnitude of AB bar is what? Under root of square of the magnitudes of X value, Y value, and Z value. So AB bar and BA bar, that is the answers. In the last class, we were discussing something about vector additions and vector subtractions. On that day, I had made you some logical analysis, but here I had made some diagrammatical point of view to understand clearly. So this is the vector of O and A bar, O and B bar. So both are separate vectors. If both are joined at O, so this is the starting point, ending point, starting point and ending point. So this is the starting point of OA bar and ending point of OA bar. This is the starting point of OB bar and this is the ending point of OB bar. Then what will be the resultant in between A and B? Right? So what is the end point of B? Starting point or ending point? In the diagram. End point of B is starting point or ending point?
Ending.
B.
Starting point.
Starting point.
A.
End point.
So the resultant is addition. So the resultant is vector addition. Right? Are you able to get it or not? So the resultant vector is C bar, or we can call it as AB bar. Even we can call it as AB bar also. AB bar, that can be called as C bar. That is equal to A bar plus B bar, or that is equal to AB bar. So when we are going to add the two vectors, if the resultant of the two vectors are of two different positions or same positions, two different positions,
Different positions.
then that is the resultant. For example, if you see the subtraction, for example, if OA bar, OA is the A bar. Why? Because starting at O is nothing but origin. You can barely take it as, if it is represented as O, that is nothing but the origin only. Mostly, if it is not origin, he will represent it. He will make it in your writing that O is not an origin. Then OB represents B bar. If I join both at the origin, this is OB bar vector, OB B bar vector, OA A bar vector, right? Then what will be the resultant of this between A and B? Endpoints of A and B. What is the endpoints of A and B? Same endpoints or different endpoints? Same endpoint.
Same endpoints.
So the resultant of these two vectors is subtraction of one vector on the other. Are you able to get it? So if the direction is from A to B, it becomes B bar minus A bar. If you take the direction from B to A, then the resultant is A bar minus B bar. Mute. Okay. So I think now can you analyze when do we go for the addition of the vectors? Then when do we go for the subtraction of the vectors?
Yes, sir.
If the resultant of the two vectors, Somebody, please. If the resultant of the two vectors is same endpoints, either starting point or ending point, whatever it may be, then it is subtraction. If the resultant of the two vectors is of different endpoints, one vector different point, other vector the different point, either starting point or ending point, or head and tail, whatever you can call it as with the words, then that resultant is what? Addition. So this is how we will go for vector addition and vector subtraction in the coming classes. Right? So keep it in mind. This is the final analysis. How do we go for addition and subtraction? Any doubt in this? No. Okay. So suppose any vector can be represented as in Cartesian coordinate system. A bar is equal to ax into ax bar plus ay into ay bar plus az into az bar. Ante if you take Cartesian coordinate system, it has three components, x, y, and z. So component of x of a vector is ax. Component of y of a vector is ay. Component of z of a vector is az. So a bar is equal to ax bar plus ay bar plus az bar. Then what is the modulus of this vector? Under root of magnitude. The value before the unit vector is its magnitude. The value before the unit vector is its magnitude. So under root of ax square plus ay square plus az square. Right? So this is how do you find the magnitude of any vector? How do you find the magnitude of any vector? If anyone asks the question, sir, what is the component of a bar vector along z axis? What is the component of a bar vector along z axis? Means az. Component means its magnitude. Here I had given it as az, but even I can take it as some values. 3ax plus 5ay plus 8az. Sir, what is the component of a bar along z axis? 8. 8. If it is 8, it is 8. Component means the magnitude of that vector along that direction. If anyone asks the question, sir, what is the component of a bar along x-axis? It's the magnitude. If any value is there, that value is the component of a bar along x-axis. Component means its value. Component means its value. Right? So here, this is the procedure. This is the procedure. So to find the magnitude from the vector. So if b bar is another vector is there, if b bar another vector is there, b bar is equal to bx ax bar plus by ay bar plus bz az bar. So what is the magnitude of b bar? Under root of bx square plus by square plus bz square. Suppose, have you got two questions, some of poll questions?
Yes, sir.
Two.
Yes, sir.
Okay.
Yes, sir.
Right. Okay. So here AB bar. So suppose if A bar plus B bar, can you say I had written only the product of two vectors. If I ask the question, if A bar plus B bar, what do you mean by A bar plus B bar? Any one of you, can you say this? Addition of two vectors. A bar plus B bar. AX. What is A bar here given? AX bar plus AY plus AZ. So add the component of X values. A bar plus B bar is equal to AX plus BX. So actually, I had given one question. AX plus BX into AX plus AY plus BY into AY. Addition means just add the magnitudes directly. X magnitude with X magnitude, Y magnitude with Y magnitude, Z magnitude with Z magnitude. If it is plus A bar plus B bar. If it is A bar minus B bar, just subtract the values, right? Then what is the values of A, B bar? End point minus starting point, single vector. End point minus starting point. So BX minus AX into AX bar plus BY minus AY into AY bar plus BZ minus AZ into AZ bar. So how do you get the magnitude of AB bar? Till now we have seen the magnitudes of A bar and magnitude of B bar only. Then how do you get the magnitudes of AB bar here? Same thing.
Root of.
Under root of magnitude of square of magnitude of x component. What is the magnitude of x component? Bx minus ax. So under root of bx minus ax whole square plus by minus ay whole square plus bz minus az whole square. This is how do you find the vector values and the magnitudes of a single vector or the two vectors. Two vectors means the vector starting from origin or the vector starting from one point to other point. So this is the analysis, right? Suppose if x, y, z values are not given, so only position vectors are represented as r and r1, r bar, r1 bar. They are starting at zero and ending somewhere else. So one vector is given as r bar, another vector is given by r1 bar. This r bar and r1 bar is nothing but the resultant value of one vector, other vector. So both are ending with same endpoints or different endpoints?
Same endpoint.
Same endpoint. So resultant will be addition or subtraction?
Subtract.
Subtract.
So resultant is noted by r bar. So r bar is equal to r1 bar minus r bar or r bar minus r1 bar, depending upon the direction. Bottom to top or top to bottom. Suppose if coordinate values are not given. Suppose if coordinate values are not given, if only position vectors are represented directly. Please keep it in mind. Again, I am repeating this. This is very, 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 very important. Very, very important. Even in GATE exams also, you'll get the questions like this. At least one question, 2 marks question, depending upon these vectors, dot product, cross product, or the component of any vector, something like that. When GATE and IES and in any competitive exams, definitely for EMTL, you will get 10 to 15 questions, marks of questions. So please, if you are very much perfect in the basics, at least you can read the question. If you are able to read the question, means you can solve it. That's not a problem. Most of the people has a fear that they will not even read the question of EMTL. Why? Because they are very much not funda in the basics. These are simple now. Even a simple question also, just by seeing that, okay, this is related to EMTL. I will not touch it. But that is a false statement. That's a bad habit. So these are the basics. What I thought it is more useful for you people, for the students, so such that you can use everywhere directly without hesitation. So till now we studied about representation of the coordinate systems at this point and this point. And here instead of coordinate systems, if it is represented in the position vector form as r bar and r1 bar, whatever it may be, I want the vector value. So here one vector is represented as r bar, other vector is represented as r1 bar. Then the resultant is noted as capital R bar, for example. Resultant you can take it by any value, but as an analysis, but as our procedure, but as our habit, we always represent the distance in terms of r. We always represent the distance in terms of r. Due to that reason, capital R is taken as the resultant value and small r is represented by the position vector distances. Just by habit, distance r or the radius r. Right? If it is, for example, a bar, instead of r bar, it is given as a bar. Instead of r1 bar, it is written as b bar. Okay, no, fine, well and good. You can take it. There is no objection in that. So what will be the resultant of r bar, capital R bar? A bar minus b bar or b bar minus a bar. If the position is from top to bottom, bottom to top. Then how do we get the magnitude of this r bar is equal to r1 bar minus r bar whole square. Anything. This is the vector value, some answer, some value. So under root of square of that resultant answer is nothing but the magnitude of the resultant. Right? Any doubt in this? Why? Because next we are going to do one problem, Amma. If you have more clarity about this, then I think you can answer this. Any doubts? We have only 10 minutes more. Shall I give one question? Yeah, even the question is visible. All of you write this question. All of you take the pen and paper and write this question and post these answers in the chat box. if A is equal to 10x minus 4ay plus 6az. And all of listen here, Amma. Okay, nisham. B is equal to 2ax plus ay. Here the z component is not given. What do you mean by this?
Z equals to 0.
0. Right. Good. Very good. Excellent. So here z is not given means it represents 0 value only. First one, I got only one person has given me the answer. Only one person has given me the answer. 2, 3. I want, how many are present now? 147. I want at least 147 answers. But excellent, Amma. Very good. Even with this online classes also, almost all the people are giving me the correct answers. Whatever we expected in the classroom, same thing. Oh, everyone is giving a very good correct answer, at least for the first option. Is this chat box visible to everyone? So one has given 35.735. Okay, good. 35.73. 35.73. At least I'm getting some multiple answers. So here, what is the first option, Amma? What is the first component? The component of A, capital letter always represents vector. Capital alphabet always represents vector. So component of A means what does it give the meaning? Component of A means what does it give the meaning? About vector. A vector. A vector along which direction? X-axis or Y-axis or Z-axis? X or Y or Z, Amma?
Y.
Y. So if you see the A vector, A is nothing but 10x, means the component of A vector along X is how much? Component means magnitude. Component means 10. But here we asked about X or Y? Y.
Y.
So the answer is -4. Component means magnitude. Component means magnitude. Magnitude of unit vector ay of a vector. Magnitude of A vectors along AY direction, along Y direction. So the answer is -4, Amma. What is the component of A along Z axis?
6.
What is the component of B along Z axis?
0.
Right. Good, very good. What is the component of B along X axis?
2.
So I think by today's class, you can say what is the scalar value, what is the vector form, what is the position vector, what is the distance vector, dot product, cross product, addition of vectors, subtraction of the vectors. Then if vectors are given directly as R bar, R1 bar, I think you can get the answer. Yes. Mute. Yeah. So I think this is what we have studied in this today's class. Almost all the people has given the answers except some. Okay, the 35.75 is second answer, I think so. Okay, good. Okay, very good, Amma. So then what about the second answer? Even I had the solution for you also in the next slide, but I think this solution is not required for you. Why? Because all the people are doing it perfectly. Then do the second one. So the second one is easy. The magnitude of 3a minus b. What is 3a?
30.
Multiply. Right.
Plus
Good.
8.
Good. So multiply the vector a. Multiply the vector a with 3. Means 3 into 10ax, 30x, minus 3 into 4ax, 12ay, plus 6 into az, 3 into 6 into az, and 18ax, 30x, minus 12ay, plus 18az, minus b. So b is as it is. So what is the answer for that?
28 AX.
Hmm.
13 AY
Okay.
plus 18 AZ.
But do you require the resultant of 3a minus b, the resultant vector of 3a minus b, or magnitude of that?
Magnitude.
Magnitude. So that point is more important. So here we require the magnitude. Then how do we get the magnitude?
Square
By under root of
Square root of the
28
component.
a square plus 13 a square.
Plus
Under
13
root
up,
of
minus 13 up.
minus
plus
30.
Okay. Okay. Plus 18. Even you even had given my answer also. So the first one, the component of A is along AY, that is AY is equal to minus 4. Second one is 3A minus B, that is equal to 3 into 10AX minus 4AY plus 6AZ minus 2AX plus AY. So 30 minus 12 plus 18 minus 2AX plus AY. So 30 minus 2 plus minus 12 minus 1. So Z is not there, so we'll take it as 0. Plus 18 minus 0 is Z bar. So the resultant is 3A minus B is equal to 462. 28AX minus 13 AY plus 18 AZ. Right? But we want magnitude. So we have to see each and every word what is present there. The notation and the representation is more important, Amma. Then I think, what about the third one? Third one, I think it requires some analysis. If we do the third one, then I think I can accept you that you understood about everything about the vectors, unit vectors, scalars, and all those things. Third one, what is third one? Third question.
Unit vector along A plus 2B.
2b. First, we have to find A plus 2b.
Yes, sir.
A is as it is. What is A?
10AX minus 4AY plus 6AY.
Yeah. Okay. Then what will be 2b?
4AX plus
4AX plus 2AY.
2ay. Right. Find the resultant of that. First, to find the resultant vector analysis of 4a A plus 2b.
14AX minus
10AX
plus
minus 2AY plus 6AY.
plus 2
So that is the resultant vector of A plus 2b. But what we require?
unit vector.
Unit vector.
Unit vector. Unit vector of what is the definition of unit vector? Definition of A, unit vector of A. What is the definition of unit vector of A? A bar by modulus
A
of
bar
A.
by modulus of A.
A. What is the unit vector of AB bar?
AB bar by modulus of AB bar.
AB bar. Fine. What is the unit vector of A plus 2b?
A plus 2B by modulus of A
A.
plus 2B.
2b. Right. Good. Then do this analysis. Any one of you got the answer? If you get the answer, you can post in the chat box. So, right. Very good. So, some people has already done it and given the answer. Very good. Most of the people are doing this. 0.91x minus 0.13 ay plus 0.39 az. Anyone? Only some people have done the third one. So I will show the answer. My answer. So what is A plus 2b? C is equal to what is A plus 2b? 14ax minus
2AY plus 6AY.
plus 6az. So what is unit vector? That is nothing but C bar. You consider it as. So A plus 2b bar by modulus of A plus 2b. So 14ax minus 2ay plus 6az divided by under root of 14 square plus minus 2 square plus 6 square. So the answer is what? Unit vector of A plus 2b is what?
91AX minus 0.13 AY plus
plus
0.29
0.29. Good, good, very good. Then then we this is how do you do the vectors, unit vectors, scalar form, magnitudes, addition of vectors, subtraction of the vectors, multiplication of the vectors.